Dear students, very good evening to all of you guys. I welcome you on BYJU'S Exam Prep. So guys, this is your next session for formula revision, and as you know that guys, this is a very important subject and as a very big subject also for your GATE examination. And no doubt in environmental engineering also guys, we have certain formula which we have to remember for your examination purpose. And if you cover this particular session guys, you are able to revise as well as recall all the formula which is important as per your examination purpose. Okay, so before starting this session guys, please let me know audio and video is perfect from my side or not. Okay, so that we can start the session. Please write it down guys quickly. Please write it down. Audio and video is perfect. Okay guys, so let's start the session. So those who are watching this video as a first time, let me tell you about myself. My name is Krishna Yadav and I'm teaching from last 9 years guys. I have done my masters from IIT Roorkee. Generally the subjects which I deal, which is basically environment, structure, RCC and mechanics part. Okay, you can download our app as well as you are able to access the GATE free achiever series for your examination. Okay guys, there is one all India open mock test which you can give between 12th to 19th of October. You can register in between that duration, right? Okay, so let's start the session guys with a first topic, that is basically your water demand. Okay, let's start the session. Water demand. You know that guys, how to calculate the average daily water demand. Let us suppose guys, if this is a city whose population is given to us, let us consider that population is P. Okay, that population is P. And let us suppose the average per capita water demand is X. Average per capita water demand is X. Now tell me guys, if this value is not given, then how much value you will consider as a per capita water demand? Tell me guys. It should be 135 LPCD. It should be 135 liter per capita per day, right? Now we can calculate certain values which is nothing as average daily water demand. Average daily water demand, and that is equal to how much? That is equal to P into X, right? This is nothing as your average water demand, average daily water demand by the city. Okay, now similarly guys, if I want to calculate the maximum daily demand, MDD value, maximum daily demand, it is nothing as 1.8 times of Q average, 1.8 times of Q average, which you can write 1.8 into P into X. And this is nothing as maximum daily demand. Hello Santu, how are you? Quickly join the session guys, quickly join the session as well as share it to other student also, so that they can aware of this session and they can join it and get the benefit of it also, right? So average is P into X, MDD is 1.8 times of P into X, correct? So this is our maximum daily demand. Okay, now let's move to the further formula guys. Let us suppose if we talk about the Goodrich formula, I think you have aware of it. What is Goodrich formula? Goodrich formula. Goodrich formula will give us the ratio of maximum demand upon average demand. Maximum demand upon average demand, right? It is the ratio of maximum demand upon average demand. And how we can write it? It is nothing as 1.8 into T raised to power minus 0.10. Correct? Correct. So this is nothing as Goodrich formula. Now what you have to do is T should be in days, right? T should be in days. You have to put the value of T, which is nothing as duration. It is in terms of days. Clear? It should be in days, right? Now tell me guys, just I am asking a single question. Now let me know guys, if I want to find out the maximum hourly demand upon average hourly demand, then what should be the value of T which you have to put over here? Tell me guys. If I want to find out the ratio of maximum demand upon average demand, but in terms of hourly, that means maximum hourly demand and average hourly demand. Now tell me guys, what should be the value of T which you have to put over here? The time duration. The time duration. Tell me guys quickly. What should be the value of T? Not 1.8. Quickly write in the comment box guys, so that you will be also enjoying the session, right? It should be 1 by 24, right? Because you have to put the value of time duration over here in terms of days, not in terms of hours. You have to put this particular value as 1 by 24. Then only it is converted into in terms of days. Correct? Understood? Yes, yes, very nice. Very nice. Yes, it should be 1 by 24. Correct. Now let's move to the next formula, guys, which is nothing as formula for fire demand. Formula for fire demand. You know that guys, it is not possible to estimate the 100% exact fire demand. You know that, right? It is not possible to estimate the 100% exact value of fire demand. Correct? Correct. Now tell me guys, if it is not possible to calculate the 100% accurate value of fire demand, then guys still we have certain empirical formula by which we can estimate the fire demand over here, right? Still there are certain formula by which we can estimate the fire demand, but those formula are empirical formula, and please remember it guys, all these formula will give you the approximate value, not the exact value of fire demand, not the exact value of fire demand. Understood? Not exact value of fire demand. But guys, these formula can be useful to estimate the fire demand in some situation, right? So let's calculate, let's understand guys, what are these formula. First formula is Kuchling's formula, which is nothing as Q is equal to 3182 under root of P. Now what is this? This is nothing as an empirical formula which you have to remember guys, and the value of fire demand you will get in terms of liter per minute, and the value of P should be in 1000. That is nothing as your population. That is nothing as your population. Clear? That is nothing as population. Clear? Okay guys. Okay guys. The next formula is Freeman formula. The next formula is, it should be P by 10, not it should be P by 5. P by 10 or P by 5? Tell me guys. Oh, where it is? Wait a second. Yes, it is basically P by 10. Okay, so Q is equal to what? 1136 P by 10 and plus 10, and this value should be in liter per minute again guys. This value should be in liter per minute again, and the value of P is in 1000. It is in 1000. It is in 1000. Okay, let's move to the next formula, which is nothing as your national board formula of underwriter's formula. Now guys, when the population is less than 2 lakh, you can use this particular formula. It should be P by 5, not P by 10. Yes, it should be P by 5. It is not P by 10, it is P by 5. P by 5, P by 5. It should be P by 5, not P by 10 guys. Santo, it will be P by 5, not P by 10. Okay. Yes. In case of National Board of Underwriters formula, this value is 4367 under root of P 46. अरे यार ये values mistake है. Yes. Okay. Yes, 4637 under root of P bracket 1 minus 0.01 under root of P. Again, P should be in 1000. It should be in 1000, and the value of Q you will get in terms of liter per minute again, right? That is nothing as our national board formula. Now let us suppose guys, if you don't have any value of fire demand, then how much fire demand I will consider in general? In general, you can consider as a 1 LPCD. In general, the value should be equal to how much? It should be 1 LPCD, 1 liter per capita per day. You can assume this particular value guys, right? If the population is less than 50 lakh, right? If the population is less than 50 lakh, you can consider the value as 1 LPCD for your fire demand. Clear? Okay. Let's move to the next part, which is nothing as our population forecasting method. Now guys, first method is your arithmetic increase method. In arithmetic increase method, how we can write the formula, which is basically Pn is equal to P naught plus N into X bar. What is Pn? Pn is nothing as, that is your forecasted population after N decade. Forecasted population after N decades. Clear? What is P naught? Last known population. Last known population data. Last known population. What is N? N is nothing as number of decades. Okay, number of decades. N is nothing as number of decade. What is X bar? X bar is nothing as, that is basically average increase in population. Average increase in population per decade. Per decade. Per decade. Okay. Just you have to put this. Okay. You will get the population after N decade easily. Now similarly guys, we have another formula which is basically geometric increase method. In geometric increase method, the formula is Pn is equal to P naught bracket 1 plus R divided by 100 raised to power N. Now you know that what is P naught, what is Pn, what is N. Now the question is, sir, what do you mean by R, right? What do you mean by R? That is nothing as average percentage increase in population, right? R is nothing as, it is average percentage increase in population per decade. Per decade. Now the question is, sir, how I can calculate this particular value? You know that guys, there are two type of approach by which you can calculate the value of R. One is your arithmetic mean and second is your geometric mean. So you can use this particular formula, that is basically arithmetic mean of the average means all the percentage increase values, that is R1 plus R2 plus Rn up divided by N. Or second, you can use the geometric mean also, right? Geometric mean is equal to what? Under root of raised to power N R1. That means this is nothing as geometric mean, R2 and up to Rn. So this is nothing as your geometric mean. So you can use this formula also. You can use this formula also. But guys, as per your examination or as per the standard condition, you have to always use as per the standard value, that is this one, right? So for theoretical purpose, please use this particular formula only to calculate the value of R, right? But for practical purpose, you can use this particular value. Now the question is, sir, why it is so? Because you know that guys, the arithmetic increase or the arithmetic mean is always greater than the geometric mean. So if you have a higher value of R, now tell me guys, if you have a higher value of R, can I say that the projected population will be higher also, right? So it will give us an extra factor of safety for future. And that is the reason guys, for practical purpose, we are using this particular formula to estimate the value of R. right? But in theoretical condition, you have to use this one only. Okay, let's move to the next formula, which is nothing as incremental increase method. Incremental increase method. So Pn is equal to P naught plus n into x bar plus n bracket n plus 1 divided by 2 into y bar. Okay, this is the formula in case of incremental increase method. Now what is x bar? You know that. What is n? You know that. What is P naught? You know that. Now the question is, what is y bar, sir? What is y bar? Y bar is nothing as average incremental increase value or average incremental increase, right, per decade. Per decade. That is nothing as our y bar value. Okay, let's move to the next formula, which is nothing as our decrease growth rate method. Decrease growth rate method. Now decrease growth rate method, guys, which is nothing as Pn is equal to Pn minus 1 bracket 1 plus r minus r dash divided by 100, right? Now in this particular case, please remember this r is what? This r is nothing as last percentage increase in population. And second is r dash. What is r dash, sir? R dash is nothing as this is average percentage decrease, average percentage decrease in percentage increase or per decade decrease, per decade. Clear? That is nothing as that is your r dash value. Clear? So there is one more formula, guys, which you can remember, but this formula is least important for your examination purpose. But let's understand this one also, guys. We'll not skip it. So by this formula, let us suppose, guys, if we have only two data, right? Let us suppose if I have two data, then how I can estimate the value of r? That is the question, right? For geometric increase method. So in that particular case, what you can do, guys, if you have two value of population like P1, which is initial known value, and the final known value, you can use this particular formula to calculate the value of r also. In this particular case, you can put the value of n, that is number of decade between P1 and P2. Let us suppose it is a 1960 and this one is 1970. So how many decade do you have in between them? Only one. So you have to put n is equal to 1 in that case. Okay, so you can use this formula also, but guys, this is the situation one in which you have only two data where you and by using two data we are trying to estimate the value of r. So you can use this one also. Okay, now I think you are able to understand all these formula. Let's understand the next one, which is nothing as logistic curve formula. Now this is the formula, guys, in which we have to put the t value in terms of year. The rest of the formula which we have used already, that should be, they are using basically the number of decades value, right? That time period is in decades, but in this case the time should be in years. Okay, let's understand, guys. So pt is what? That is nothing as population after t year, population after t year, right? So this is basically ps divided by 1 plus m ln inverse, or you can call it as log to the base e inverse bracket n into t. What is ps over here? That is basically saturation population. Saturation population. Now let us suppose, guys, if we know three data, let us consider at time t is equal to 0, the population is p0. At time t is equal to t1, it is p1. And at time t is equal to t2, the population is p2. Now usually you have to consider t2 is equal to twice of t1 value. That means, let us suppose the difference between these two duration is 10 years. So the difference between these two duration is also 10 years. That means from initial it is how much? 20 years, right? Understood? So this is P0, P1 and P2. If we know all three values, we are able to estimate the saturation population, which is nothing as PS. You can write PS in terms of PST also, PSET. This value is saturation population, or you can write here PSET also. So it is twice of P naught, P1, P2 minus P1 square bracket P naught plus P2 divided by P naught, P2 minus P1 square. And that is nothing as our saturation population. Now after estimating it, we need to find out certain constant, which is nothing as our M value and N value. So what is M? It is PS minus P naught upon P naught. PS minus P naught upon P naught. What is P naught? Initial value which is already known to us. Okay. Now again another constant is there guys, which is nothing as N. So how we can calculate N? N is equal to 2.3 divided by T1, and this T should be in year. Please remember it. This is in year. Log to the base 10 bracket P naught PS minus P1 divided by P1 PS minus P naught. Okay. So you are able to estimate the value of T, and this value of T have a unit of time inverse. Right? Time inverse. Okay. Okay. After getting this value, you have to put it so that you have a equation of logistic curve. Now guys, in this particular case, what is T? T is in year. T is time, which is in year. Not in decades, it is in year. Please remember this point. Okay. So this is nothing as this is our logistic curve method. Now let's move to the next chapter, which is basically quality parameter of water. Quality parameter of water. Quality parameter of water. Now you know that guys, there are certain quality parameter which is very important for your examination, like your suspended solid, right? In physical quality parameter, suspended solid, turbidity, right? In chemical, it is hardness. Then we have alkalinity part. If you talk about biological, in that particular case, ambient test is important because they are trying to put the question from it. Okay. So let's understand. Okay. Yes, I will explain that point also. So let us suppose, Santu, if you have log to the ln inverse value, let us suppose if you have ln inverse value, how you can solve it? Let me explain. So let us suppose ln inverse nt. So let us consider this value is equal to x, right? So can I write here nt is equal to what? It is log to the base e x, or we can write here x is equal to what? E raised to power nt. Yes or no? Now tell me, either you can write ln inverse nt or you can write e raised to power nt. It is one and the same thing because this value is also equal to x and this value is also equal to x. So in place of this, we can write this one also. So our formula will get changed over here and it will become PS divided by 1 plus PS divided by 1 plus m e raised to power nt. Right? In place of ln inverse nt, you can write e raised to power nt. Right? The answer will remain same. There is no change, but we are trying to change the formula little bit. Okay. Very nice. Okay. Let's move to the next part, guys, which is basically our physical parameter. So you know that guys, in physical parameter, there are suspended solid, turbidity, color, taste, odor, and temperature. So if we talk about turbidity, some of the things you have to remember, like turbidity rod method are there. There are basically 4 methods: turbidity rod method, Jackson turbidity meter, in which the turbidity can be measured greater than 25 unit, right? Greater than 25 unit. If we talk about Bayes turbidity meter and Naplo turbidity meter, so Naplo turbidity meter can measure the turbidity less than 1 unit, right? It can measure the less than 1 unit. And in water supply engineering, mostly we are using the Naplo meter, right? Naplo meter only. Now, if we talk about guys, the standard unit which we are using in case of Jackson turbidity meter and Naplo meter, one is basically your JTU. 1 JTU. What is 1 JTU? Anyone? Jackson turbidity unit. Okay. So guys, it is nothing as basically you need to use 1 milligram of silica in the form of SiO2 in 1 liter of distilled water, right? That is nothing as that is your 1 JTU. Similarly guys, we have, yes, 1 JTU, and the next one is 1 FTU. Next one is 1 FTU, or you can write here 1 NTU. Very nice. 1 FTU, 1 NTU. FTU means formation turbidity unit. NTU means naphtho turbidity unit, right? In naphtho turbidity unit or formation turbidity unit, you need to use 1 milligram of formation polymer, 1 milligram of formation in 1 liter of distilled water. In 1 liter of distilled water. That's it, right? That's it. That is basically your 1 NTU or 1 FTU. Clear? The next one is basically your color. Next one is color. So color is to be measured by tintometer, and in tintometer, guys, we are using a standard unit which is nothing as our TCU, true color unit. Now what is true color unit? It is nothing as 1 milligram of platinum ion, platinum cobalt basically, right? We are using 1 milligram of platinum cobalt in the form of chloroplatinate ion in 1 liter of pure water. In 1 liter of pure water or distilled water. That is basically your 1 TCU, correct? Next one is taste and odor. You know that, guys, generally we are not able to measure the taste in the water, but we are trying to observe or we are trying to measure the odor. But in recent condition, guys, as per Indian Standard Code, they have removed all the permissible value which is required for taste and odor. So guys, what they have written in the codal provision, you have to means the taste and the odor is agreeable in the water. That means the permissible value which was earlier like 1 ton TON, right, threshold odor number, and 3 ton, that has already removed, right? So updated version says whether the taste is there in the water or the odor is there in the water, it is agreeable. It is agreeable, right? Now guys, how to measure the odor? Basically by using osmoscope. The standard unit of measurement is ton, which is nothing as threshold odor number, ton. Now how you can calculate the ton? Let me explain it over here. The formula of ton is nothing as, it is volume of sample or undiluted sample, volume of undiluted sample plus volume of distilled water required to bring no odor condition, divided by what? Initial volume, that is basically volume of undiluted sample, volume of undiluted sample. So if you take the ratio, you will get the threshold odor number. But in recent year, guys, this particular formula is not useful for us. Why? It may be possible, you may get the question, you can solve it. But guys, in recent year, you know that as per the IS code, right, IS 10500/2012, as per that particular codal provision, now the odor and the taste is agreeable. So you don't have to measure it, right? I will explain about it, Santu. I will explain it about it. What is 1 ton? What is 3 ton? I have certain units and certain values which you have to remember. I will tell you about that also. Okay. Let's move to the next part. That is basically temperature. So the range of temperature which is recommended to us is in between 10 to 25 degrees centigrade. Okay. It should be in this range only. Now guys, let's move to the next part, which is basically your chemical parameter, chemical quality parameter. So you know that, guys, in chemical quality parameter, dissolved solid is the part of chemical quality parameter and suspended solid is a part of physical quality parameter. But if we talk about total solid, how we can measure total solid? Total solid is nothing as, it is the addition of suspended solid plus dissolved solid, suspended solid plus dissolved solid. The second formula which we have to remember is pH. So you know that, guys, pH is nothing as, it is a logarithmic scale to represent the H plus ion concentration in the water. Now what is H plus ion over here? It is nothing as, guys, it is our moles in per liter value. This H plus ion concentration should be in moles per liter. Okay, so this is nothing as our pH. Similarly, we can calculate the pOH of water also. That means in terms of logarithmic scale, how much amount of OH negative ion is present. So again guys, this value should be in moles per liter minus log to the base 10 OH negative ion. You know that guys, if we take the addition of these two value, which is nothing as pH plus pOH, we can write it as 14. Okay, we can write it as 14. And H plus ion concentration, which is in moles per liter, and OH negative ion concentration. If you take the product of these two value, you will get 10 raised to power minus 14, right? Okay. Now I think you are able to understand these formula. Okay. Now let's understand certain basic formula also guys, which is related to your chemical parameter. So first one is molecular weight. Molecular weight. How you can estimate molecular weight? Let's take one example. So guys, let us suppose CaCO3. If I want to estimate what should be the molecular weight of CaCO3. So calcium is how much? 40. Carbon is how much? 12. Oxygen is how much? 16 into 3. If you add all these value, you will get 100, right? And this is gram per mole. Now you can see here guys, what we have to do to estimate the molecular weight. Just you have to find out, you should know about the atomic weight of each and every element and try to take the algebraic sum of it so that you will have the molecular weight. Next one is number of moles. Number of moles. It is nothing as weight in gram upon molecular weight. Upon molecular weight. Molecular weight. Okay. Next one is number of moles. This is done. You are able to understand number of moles. Next one is equivalent weight. Equivalent weight, that is nothing as molecular weight divided by valency, right? Molecular weight divided by valency, that is nothing as equivalent weight. Next one is number of equivalent. How we can calculate number of equivalent? Number of equivalent, or it is also known as gram equivalent. Gram equivalent is equal to how much? That is basically weight in gram upon equivalent weight. Upon equivalent weight. That is basically number of equivalent or gram equivalent. Clear? Very nice. Very nice, Santu. Okay, let's move to the next one. Number of equivalent we have done. Next one is normality. Normality. That is basically number of moles or number of equivalent per liter of sample. In 1 liter of sample, how many equivalents are there? That is basically your normality. That is basically your normality. Clear? So please remember these formula. All these are important for your examination purpose. Okay. Now guys, do you remember that concept? If we have 1 gram equivalent of anything, we can convert it into 1 gram equivalent of any other thing also. So you please remember this one also guys. 1 gram equivalent of one compound is equal to 1 gram equivalent of other compound. Right? So how we can equate it? It is very easy guys. You can write here the weight in gram of one compound, right? The weight in gram of one compound divided by equivalent weight of that compound, right? Equivalent weight of first compound, right? Similarly guys, weight in gram of the second compound divided by equivalent weight of second compound. Now let us suppose guys, if the value is in milligram per liter, so what you can do, you can write here weight in milligram per liter, right, divided by equivalent weight of compound 1 is equal to weight in milligram per liter of second compound divided by equivalent weight again for second compound. You can use either of the formula guys for your calculation purpose. That means if I want to convert one compound into another compound, or if I want to find out how much amount of second compound is required to react with the first one, so we can use this formula to calculate it. Okay, I think it is understood to all of you. Now let's move to the further thing guys. Let's understand what is basically alkalinity. So you know that guys, alkalinity is mainly caused by three compounds, which is basically your three anions, right? Anions. It is mainly caused by the anions. Now what are these anions? It is nothing as negatively charged ion, negative charge ion. Now what is alkalinity? It is the tendency of water to neutralize the acid or to neutralize the hydronium ion. Hydronium ion means H plus ion, right? Now if you have more negative charge, that means it is able to react more H plus ion, right? So that means it is having more alkalinity in the water. So generally guys, we are trying to represent the alkalinity in terms of CaCO3. So how you can write it down? It is very simple. Whatever the concentration of SCO3 negative is given to us, you know that guys, there are basically three things by which we can estimate the alkalinity: OH negative, CO3 2 negative, and SCO3 negative. Hydroxyl ion, caustic alkalinity; CO3 2 negative ion, carbonate alkalinity; SCO3 negative ion, bicarbonate alkalinity. So concentration of SCO3 negative ion multiplied by equivalent weight of CaCO3 divided by equivalent weight of SCO3. Or what you can do guys, you can write in simple way also. Let me write here. Alkalinity in CaCO3 in terms of CaCO3 in milligram per liter. So what you can write here guys, it is basically weight of SCO3 negative in terms of milligram per liter, weight of SCO3 in milligram per liter divided by equivalent weight of SCO3 negative, right, plus weight of CO3 2 negative divided by equivalent weight of CO3 2 negative plus weight of OH negative ion divided by equivalent weight of OH negative bracket then multiplied by equivalent weight of CaCO3, equivalent weight of CaCO3. By using this formula, you can estimate the alkalinity part easily. Crystal clear to all of you guys? Crystal clear? Okay. Let's move to the next one guys. If I want to estimate the hardness, you know that guys, hardness is mainly caused by the multivalent cation. It is caused by the multivalent cations. Multivalent cation. Now what is multivalent cation? Whose valency is greater than 1. Whose valency is greater than 1. What is cation? Cation means positive charge. Okay. Now guys, what is total hardness? Total hardness is nothing as, it is the addition of carbonate hardness and non-carbonate hardness. And mainly you know that guys, in general in our water, main concentration is calcium plus 2 ion and magnesium plus 2 ion. So if I want to convert the calcium plus 2 ion and magnesium plus 2 ion in terms of CaCO3, how I can write it? So let me write the formula to estimate the total hardness. So total hardness in milligram per liter of CaCO3 is equal to weight in milligram per liter of calcium plus 2 ion divided by equivalent weight of calcium plus 2 plus weight in milligram per liter of magnesium plus 2 ion divided by equivalent weight of magnesium plus 2 plus OMC. What is OMC? It is not optimum moisture content. It is basically other multivalent cation. If you have other multivalent cation whose valency is greater than 1, still you have to consider it. Okay, so that part is missing over here, so we will write here, guys. It is basically equivalent weight of other multivalent cation. Put the bracket and multiply it by equivalent weight of CaCO3. Equivalent weight of CaCO3. So what is OMC? I am writing here, guys. OMC is nothing as other multivalent cation. It is not optimum moisture content. Okay, other multivalent cation. Clear? Let us suppose, guys, if you have Fe plus 3, if you have Mn plus 3, Mn plus 2, right? So in that particular case, you have to write it, right? So that it can give some hardness to the water, and we have to estimate it also. Okay. Now it is clear. Now you know that, guys, there are basically two types of hardness which is present in the water. One is carbonate hardness and second is non-carbonate hardness. Carbonate hardness is mainly due to carbonate ions, which is basically CO3 negative and SCO3 negative. That means when calcium and magnesium are trying to react with these ions, then ultimately, guys, we will get the carbonate hardness. Second is if we have calcium and magnesium and they are trying to react with the chloride, nitrate and sulfate, right? If they are trying to react with these compound, then ultimately, guys, we will get again the hardness over here, right? Chloride, nitrate and sulfate. So calcium and magnesium are trying to react with these compound, then we will get the non-carbonate hardness, which is also known as permanent hardness, Now you know that, guys, there is one formula to estimate the carbonate hardness. If you know the alkalinity part, if you know the total hardness of the water, if you take the minimum of these two values, you will get what? Carbonate hardness. If we know the total hardness, if we know the alkalinity, if we take the minimum of these two, we will get the carbonate hardness. Right? So after getting carbonate hardness, it is very easy to calculate the non-carbonate hardness. We can write here, guys, non-carbonate hardness is equal to what? Total hardness minus carbonate hardness. So we'll get the answer of both the things, which is non-carbonate as well as the carbonate part of the water. Clear? Next thing is your permissible values, which you have to remember, guys, like turbidity. You know that, guys, turbidity permissible value is 1 NTU and 5 NTU is cause for reaction. Now the question is, sir, what is the difference between the permissible limit and the cause for reaction? Let me explain it first, then we'll come back to this one. What is the difference between these two? Let me explain. Let us suppose, guys, right now this is our treatment plant. Okay, I'm explaining, guys, what is the difference between the permissible limit and cause for rejection. Let us suppose this is our water treatment plant. And this treatment plant has a capacity to treat the water of 90%. That means any impurity can remove up to 90% only. Okay. Let us consider, guys, the raw water which we are trying to supply inside the treatment unit having a turbidity of 10 NTU. Okay. Now tell me, guys, after the treatment, what should be the turbidity which is present in the treated water? Tell me, guys, what should be the turbidity of the treated water? If you remove the 90% of turbidity, so how much turbidity will be there in the treated water? Tell me, guys. Please write down in the chat box. I am reading your comment. Please write down. Please write down, guys. It is a very simple question, yaar. 90% of turbidity you have removed. That means only 10% is remaining. So what should be the value of 10% of this 10 NTU? It is 1 NTU, yaar. It is 1 NTU. Now tell me, guys, in your treated water, the amount of turbidity which is present is how much? It is 1 NTU. Now whether you will allow this water to the consumer or not, whether you will allow this particular water to the consumer or not. Tell me guys, it is a very simple question. You will allow this particular water to the consumer or not? Yes, definitely we will allow it, because as per Government of India, what they have suggested, the permissible limit is 1 NTU only. So we can allow this particular water to the consumer. There is no issue, right? And this is right now a general condition. Okay. But let us suppose guys, if we have second one, let's take the second condition, right? Let's take the second condition. Let's take the second condition. Now let us suppose, again, we are having the same water treatment plant whose efficiency is 90% only, right? 90% only. Now let us consider guys, the turbidity which is present in the water or in the raw water has increased. Now why it has increased? Listen, why it is increased? Let us suppose guys, if some excessive soil erosion has occurred, and due to that reason in river water we have lot of concentration of suspended solid. Second thing, it may be possible due to landslide, the water may get turbid more, right? Lot of amount of soil is there guys, which is present in the water due to that reason also. So these are nothing as, these are some you can say that some uncertain events which may occur in future, and we are not able to predict it. And as well as guys, due to that reason your quality of raw water may get deteriorated, right? Or it may get decreased. So that is the reason guys, due to which you can understand the turbidity has increased right now. And let us suppose right now it is 100 NTU value. Okay, 100 NTU value. Now 90% we are able to treat. Okay, only 10% is passing in the treated water. Now our treated water will have a turbidity of what? 10 NTU. Now tell me guys, whether you will allow this particular water to the consumer or not. Kindly check this. The maximum permissible value which is recommended by Indian Standard Code is 5 NTU. That means in any scenario or in any condition, we are not able to exceed this particular value. That means it is a cause for rejection. After this particular value, if you have a turbidity inside the water, we will not allow that water to the consumer in any scenario, whether they are getting the water or not, it doesn't matter. The first thing is, you will not allow to supply that water to the consumer if the turbidity is greater than 5 NTU, right? So in this situation, we are not able to allow it. And such situation will occur in some uncertain events or unconditional things like landsliding, excessive soil erosion, excessive disposal of sewage, and etc. So due to that reason, your turbidity or your water quality may get deteriorated, and ultimately this raw water will have lot of impurity. And we know that guys, that treatment plant have a certain capacity to treat the water. So after that guys, again we have to measure what should be the value of any type of impurity which is present in the raw water, whether it is matching to the permissible limit or not. Now let us suppose guys, due to the same situation, now the turbidity is 50 NTU. 50 NTU. Now after treatment, this value will become how much? 5 NTU. Now tell me guys, whether I will allow this water or not. Yes, we will allow it. We will allow it, right? We will allow this particular water to a consumer, because we don't have any other sources. We don't have any other source to take the water and treat it and to supply it, right? So that's why we have to use this particular source only, in which the turbidity is right now 50 NTU. But again guys, as compared to in general condition, we are trying to supply a little bit higher value of turbidity. But this turbidity is allowed to the consumer in certain scenario, when you don't have any other source to supply and treat the water. That is the reason. Clear? That's why it is known as cause for rejection, or it is also known as permissible limit in the absence of alternate source. So this cause for rejection is also known as permissible limit in the absence of alternate source. Clear? Okay. Now for color, it is given as 5 TCU and 15 TCU. Now you can see here guys, For taste and odor, they have mentioned the value as a agreeable. It is not 1 ton and 3 ton. No doubt, before 2012, the value was 1 ton and 3 ton. If someone asks you guys, you can write here, right, in terms of ton. But in general, it is agreeable in nature, right? If we talk about TDS, total dissolved solid, 500 milligram per liter and 2000 milligram per liter. Alkalinity, 200 milligram per liter, 600 milligram per liter. But this value should be in terms of CaCO3. Please remember it in CaCO3. pH value 6.5 to 8.5. The same value is applicable over here also. Hardness 200 and 600, again in terms of CaCO3. In terms of CaCO3. Chloride contain 250 and 1000 milligram per liter. Fluoride 1 milligram per liter and 1.5 milligram per liter. Clear? Please remember all these values. All these values are important. Now if we talk about nitrogen content, as per Government of India, after 2012, what they have changed, basically you can add these two ammonia, free ammonia and organic ammonia. So you will get the total ammonia or Geldar's nitrogen, right? So this ammonia has a permissible limit of 0.5 milligram per liter, right, as permissible limit, and cause for rejection is same also. That means it is also 0.5 milligram per liter. But earlier was, they have mentioned it separately. Means before 2012, they have mentioned free ammonia separately and organic ammonia separately. And this is after 2012. After 2012, right? So you can see here guys, earlier it was 0.15, 0.15, 0.3, 0.3. But in recent year, you should know about this particular value, which is total ammonia, which is addition of these two, and it is 0.5 and 0.5. Clear? Nitrite, it is 0 because it is highly dangerous. Nitrate 45 and 45. Clear? You know that guys, if we add these two ammonia, we will get the Geldar's nitrogen. Clear? Let's move to the next formula, which is nothing as our biological parameter, in which we need to understand the MPN formula, which is given by Thomas, right? So let us suppose guys, if you don't get the standard table of MPN, so how you can calculate the MPN? You need to write number of positive tubes. That means those tubes which are giving the positive result. So number of positive tubes divided by under root of volume of ml of sample in negative tubes multiply by volume of ml of sample in all the tubes. And I think you know this particular formula. Let me show you one thing so that everyone can understand it. Let us suppose guys, we are having 5 tubes of 0.1 ml, 5 tubes of 1 ml and 5 tubes of 10 ml. 0.1 ml, 1 ml and 10 ml, right? Let us consider guys, out of 5 tubes, 3 tubes are giving positive result. In this particular case, 2 tubes positive result and 1 tube as a positive result. Clear? So this is basically number of positive tubes. Clear? Similarly guys, we can estimate the negative tubes also. So out of 5, 2 tube will be negative, 3 tube will be negative, and over here 4 tube will be negative. Clear? Now tell me guys, it is easy to estimate the volume of sample in all negative tubes. Can we estimate it? Yes. There are basically 2 tubes of 0.1 ml plus 3 tube of 1 ml plus 4 tube of 10 ml. So can you estimate this value? Yes sir. Can we estimate volume of all the tubes? Which is also very easy. Total tubes are 5 plus 5 plus 5. That means 15 tubes. So 5 whose volume is 0.1, 5 whose volume is 1 and 5 whose volume is 10. You can estimate this volume also. Clear? How to do it? Crystal clear, guys? Okay. Let's move to the next chapter, which is basically our treatment part. Let's move to the next chapter, which is basically our treatment of water. So in treatment of water, you know that, guys, one of the major thing which is basically your sedimentation. So sedimentation will have two type of sedimentation. One is plain sedimentation, second is sedimentation with coagulation, right? And in sedimentation tank, guys, what is plain sedimentation? In which we are not using any kind of coagulant, right? So that we can if you use any kind of coagulant in the water, that means you are trying to increase the size of particle. That is the purpose only, right? But in plain sedimentation, we are not doing it. If we talk about sedimentation with coagulation, we have certain fine particle or smaller suspended solid. So our task is to increase their size. That's why we are using the coagulant, so that we can form the sticky PPT, and ultimately these particles will attach over it, and ultimately our size of particle will get increased. And that is the purpose of sedimentation with coagulation. Now, guys, sedimentation tank, we will have two type of tank. One is fixed type, which is also known as fill and draw type, in which we'll put the water for 24 hours, then we have to empty it, right? Continuous flow type, that means in this particular tank, the water is continuous flowing inside the tank. That is basically continuous flow type sedimentation tank. Clear? Now, guys, you know that there is one formula to estimate the settling velocity of particle. So Vs is equal to how much? It is nothing as under root of 4 by 3 bracket G minus 1 G into D divided by CD. Right? Now, this is nothing as, this is the general formula to estimate the settling velocity of particle. General formula to estimate the settling velocity of particle. So what is Vs? It is settling velocity of particle. Settling velocity of particle. What is G? It is specific gravity of particle. Specific gravity of particle. What is small g? You know that, guys, its value is 9.81 meter per second square. D is the size of particle. D is size of particle. What is CD? It is drag coefficient. Drag coefficient. Now, this drag coefficient will depend upon what? It will depend upon the size of particle which we are having, right? So basically, guys, there are three size range which is given to us. If the size of particle is less than 0.1 mm, if the size is greater than 0.1 mm and less than 1 mm, and the size is greater than 1 mm, then, guys, we are having three type of condition. One is laminar for this situation, transition for this one, and turbulent for this one, right? So what is the value of drag coefficient? Let me write it down. We will discuss separately what is Stokes' law. So CD is equal to what? 24 by Re plus 3 by root Re plus 0.34. So this is the value of drag coefficient when you are having laminar situation. That means D is less than 0.1. Clear? When you have, sorry, this is for transition, not the laminar one. For laminar, it is 24 by Re only. 24 by Re. For transition, it is 24 by Re. Sorry for this. 3 by root Re plus 0.34. For transition, you have to use this formula. For transition, you have to use this formula. Now, if you have turbulent condition, then the value is 0.4, right? 0.4. For turbulent, the value is 0.4. Clear? Now, you know that, guys, you know that as per Stokes' law, we have to choose this situation. That means laminar situation, in which D value is less than 0.1 mm and CD is equal to 24 by Re. If you put CD is equal to 24 by Re, then what formula you will get as per the Stokes' law? Let me show you that. Okay. Now you can see, guys, as per Stokes' law, the formula will become 1 by 18 nu D square bracket G minus 1 into G. Correct? Now what is mu? Mu is nothing as dynamic viscosity. whose unit should be in Newton second per meter square. Clear? So this is our settling velocity as per the Stokes law. Now let us suppose guys, if I want to convert the dynamic viscosity in terms of temperature, so you can do it also, right? So you can use this formula to estimate the settling velocity of particle, but in terms of temperature, right? So you can write here guys 418 bracket g minus 1 into d square bracket 3 T plus 70 divided by 100. T is nothing as that is basically temperature. Clear? Next one is turbulent guys. For turbulent situation, you can use this formula also, which is 1.8 under root of g into d g minus 1. That is for turbulent situation. But guys, to be true, let me explain one thing over here. In your water treatment plant, mostly your water treatment units are working in the laminar situation only. That's why you have to use the Stokes law. But in case of wastewater treatment plant, you have to use the laminar, transition and turbulent. All three situations are there in various units, right? So that's why guys, in wastewater treatment plant, we have to use these three situations. But if we talk about water treatment plant, mostly you will get the laminar situation only. Okay. Next one is, what is surface overflow rate, SOR? So let me draw one figure first. Let us consider guys, this is our tank, sedimentation tank, and let us suppose a discharge which is basically our design discharge which is coming to this tank, right, which is QD, or you can write here Q also. Okay, let us suppose this is length of the tank, this is width of the tank, and this is H of, means height of the tank, right? So we can write here the surface overflow rate, SOR. Surface overflow rate is nothing as, it is Q by B into L. That means that is basically our surface area. Q by B into L. That is basically our surface area, right? Or you can call it as design settling velocity also. Design settling velocity. So design settling velocity is equal to how much? It is basically Q upon BL. Right, that is basically our design settling velocity. Okay, now guys, if I ask you what should be the flow velocity of a particle, VF, so VF is equal to how much? Q divided by B into H. That is basically cross section area of the tank. So VF is equal to how much? It is basically Q by B into H. Okay. Now, if you want to estimate what should be the detention time for the tank, how you can estimate? So detention time is equal to how much? It is nothing as volume upon design discharge. So volume is what? B into H into L divided by design discharge. By using this formula, we are able to find out the detention time of the tank, T, D. Clear? Okay. Now guys, there is one more formula to estimate the volume of the circular tank, right? In case of circular tank guys, the volume should be what? D square bracket 0.785 H plus 0.011 times of D. Now let me show you something over here guys, which you can use in your examination also. Let us suppose this is our circular tank. This is our circular tank, okay, in which the top portion is cylindrical and the bottom portion is hopper bottom, like this. So this height is basically H. This height is H. And the dia of the tank is capital D. But let us suppose guys, if I want to find out the total volume of the tank, how I can find it out? The total volume of the tank can be written as D square bracket 0.785 H plus 0.011 times of D. By using this formula, you can estimate the total volume of the tank. But let us suppose guys, if I want to estimate the settling velocity of particle, or SOR, surface overflow rate. So what you have to write? Design discharge divided by surface area. Now in this case, what is the surface area over here? That is basically pi d square by 4. So you need to write design discharge divided by pi d square by 4. By using this formula, you are able to write the SOR. Okay. Now guys, If I want to estimate the detention time, so detention time can be written as volume upon design discharge. So in this case, please put the value of volume which you have calculated earlier, which is this one, not pi d square by 4 into h. That is the volume of cylindrical portion only, but you have to consider the volume of conical, means hopper bottom also. Okay. Now there is one more term which is known as wear loading rate. Okay. So what is wear loading rate? The rate by which wear is loaded, or you can call it as discharge per unit length of wear. Simple, right? So this is basically design discharge divided by length of wear. So let us suppose, guys, if you have a rectangular tank, in that particular case, they will give you the length of wear easily. So you have to write LW. Okay. So you will get the unit in terms of meter cube per day per meter. Clear? But let us suppose if you have a circular type of sedimentation tank, in that particular case, what you have to write, guys, basically the parameter should be like this. So your water will overflow in this particular channel in which you have to collect it, and ultimately after collecting this particular water, guys, will allow this water to move into the next treatment unit, right? So in this case, the parameter is what? Pi into d. So for circular tank, wear loading rate is equal to QD by pi d. QD divided by pi d. Clear? Next is mixing basin, or you can call it as rapid mixing, which is known as coagulation, and slow mixing, which is known as flocculation. Slow mixing, which is also known as flocculation. Okay, rapid mixing and slow mixing. Now guys, let us suppose if you are using any kind of mechanical mixer to mix your water inside the rapid mixer, inside the slow mixer, that means coagulation and flocculation. So what you have to do, guys, you need to use a motor, and through that particular motor you have one rod, and that rod is connected with an impeller, which is this one, right? And by using it, we are able to rotate this particular rod. So this particular impeller is also rotating. Now this impeller will have certain surface like this, which is also known as plate, right? Like this. Now if you rotate it, what will happen? Imagine this particular situation, guys. What will happen? Through this particular surface, we are able to mix the water easily, right? So that's why, guys, you need to remember certain formula to estimate the power of that particular motor. So let me write the formula first. Let us suppose, guys, this is our rod through which an impeller is connected, and through this impeller we are having certain plates like this, right? Let us consider the surface area of the plate is P into L. Okay, and this particular rod is rotating with N RPM, number of revolution per minute, right? So can we estimate the angular velocity? It is very easy. Angular velocity is 2 pi n by 60. Okay. Now let us suppose, guys, if I want to estimate what should be the velocity of plate. What should be the velocity of plate? So let me show you in this way also. So guys, if we see this particular condition from this end, so how it look like actually? Like this, like this. Okay. Now guys, you know that this particular rod, this is rod basically rotating with an angular velocity of omega, right? But I wish to estimate what should be the velocity of paddle, or what should be the velocity of plate. Okay, that is known as VP, right? So you need to know what should be the distance between the center of paddle to the center of rod. Let us consider that is basically R. Okay. Okay. So can I write here, guys, the velocity of paddle is equal to what? Omega into r. Omega into r. Let us consider the velocity of water by which water is also rotating, which is VW, right? When you try to rotate this particular rod, so water is also trying to rotate, correct? So we are able to estimate the relative velocity between the paddle and the water. So this is nothing as relative velocity of paddle with respect to water. Okay, so you can see here, guys, both the component are in same direction, so we can write here Vp minus Vw is nothing as Vr. This is basically Vr. Now after estimating Vr, what you have to do, guys, you need to find out the drag force. So drag force is equal to 1 by CD rho W into area of paddle into Vr square. What is area of paddle? AP. AP is nothing as, that is basically area of paddle. So how many paddle are connected over here? 2. So what is the area of one paddle? B into L. So how many paddle we are having? 2. So what should be the area of paddle? Projected area of paddle? 2BL. Projected area of paddles. So it is basically 2 times of B into L. Okay. After putting all the values, guys, and CD is drag coefficient, this value is generally given in the question, right? This value is generally given in the question. So after estimating the drag coefficient, after estimating the area of paddle, you are able to estimate the drag force. Now after calculating the drag force, guys, what you have to do, power is equal to drag force into relative velocity, right? So in this way you are able to estimate the power which is required. Now there is one more formula, guys, which is trying to relate this particular power with the temporal mean velocity gradient. So power we can write here G square into volume of the tank multiplied by dynamic viscosity. So G is equal to how much? It is nothing as under root of power divided by V and nu. What is V? V is volume of the tank. So we can write here G is equal to what? G is nothing as temporal mean velocity gradient. Temporal mean velocity gradient. Okay. So we can write here G is equal to how much? Under root of P. P is equal to how much, guys? It is drag force. Drag force is half CD rho W AP into VR square multiply by how much? It is VR divide by how much? It is V and mu. So by using this formula, you are able to estimate the temporal mean velocity gradient easily. Clear? It is clear to all of you, guys? Tell me. Very nice. Okay. All of you are able to understand this, how to estimate the temporal mean velocity gradient. We have discussed it, right? Let's move to the next part, which is rapid sand filtration, right? So in rapid sand filter, you know that, guys, there are a certain formula to estimate the number of filter bed and to estimate the design discharge and etc. Okay, so let's understand it. So first thing which you have to calculate is your maximum daily demand. Okay, QMDD. So QMDD is 1.8 times of Q average, right? Which is also written as 1.8 times of P into X. And that is basically our maximum daily demand. Okay. Now after estimating it, let us suppose, guys, if in the objective question, it is not mentioned, you have to consider like 5% of the water or 2 to 5% of the water for your backwashing purpose. If it is not mentioned, then you can use this formula as a design formula. Okay. If no other value are given, then you can use it as design value. Okay. You can use it as design value. But let us suppose, guys, if amount of backwashing water is considered, then guys, in that particular case, this should not be the design formula, right? This should not be the design formula. So our new value will be what? Generally guys, they are giving a range like 2 to 5%, and mostly we are using 5%. So I'm writing 5% over here. So what you can write here guys, this should be QMDD plus 5% of MDD. Yes, very nice. 5% of MDD value, right? That means 1.05 times of QMDD will be our Q dash. It will be our Q dash, right? Now guys, after this, let us suppose no other data is given. So we will consider this value as a design value. But let us consider, still they have mentioned one more terminology. Let us consider if the backwashing duration is only 23.5 hour, right? And we need 30 minutes at least for our backwashing purpose. So can I say that guys, in actual duration or the actual operation duration should be 23.5 hour only? So let us consider if TB is the time of backwashing. How much time is required for backwashing purpose if it is given? So guys, the actual operation duration or actual filtration duration is equal to how much? Can I say that 24 minus TB? 24 minus TB, and this TB should be in R. You will get actual duration of filtration. So we can estimate the actual design discharge over here. How we can write it? Q dash multiplied by 24 divided by 24 minus TB. So after this guys, you will get your design discharge. So if you consider both of the parameter, you are able to understand guys how to calculate the design discharge. So this is our design discharge, right? This is our design discharge. Now after having the design discharge, are you able to calculate what should be the area, surface area required? So surface area of filtration or rapid sand filter. So guys, this surface area is nothing as basically design discharge upon rate of filtration, or sometime they have given filter loading rate also. It is rate of filtration or they will give you the filter loading rate. Filter loading rate. Okay, clear? So by using it, we are able to estimate the total surface area of the filter which is required. Clear? Now after estimating it guys, there are two choices which we have. Either they will give you the direct area of one filter unit, or you have to use a formula to estimate how many number of filter unit are there. So let us suppose guys, there are two situations I am writing here. If area of one filter unit is given, if area of one filter unit is given, let us consider that area is A dash. Can we estimate the number of filter unit required? Number of filter unit required, how much it is? So can I write here guys, this total area divided by one area. We are able to estimate the n value, right? This is one of the situation. Second situation is that guys, if this particular value is not mentioned, that means A dash is not given to us. So we have an empirical formula which is n is equal to 1.22 under root of Q design, and Q design should be in MLD, right? And you will get the number of operational unit, number of operational unit. Crystal clear guys? How to do it? Tell me, it is crystal clear to all of you how to do it? Crystal clear? How we can find out the number of unit in case of rapid sand filter? It is very easy. And what should be your design discharge? That is also easy, guys. We have already discussed what are the steps which you have to follow. Clear? Okay. So let's move to the next one, guys. Let's move to the next one. Let us suppose, guys, if the backwashing situation is there, right? There are two conditions. Let me explain. Backwashing condition. Right? So this is basically nothing as this is the analysis which is related to the head loss, hydraulic head loss during backwashing. Okay. Hydraulic head loss during backwashing. So guys, there are two situations which will occur. One is the filter bed initially it is not expanded. In the second case, after backwashing, it will get expanded. Correct? It will get expanded. Right? So this is first situation. Let us suppose the depth is D, and this is the second situation in which the depth is D expanded. Right? So guys, this is unexpanded filter bed, and this is expanded filter bed. Expanded filter bed. Okay. Okay, sir. Now guys, there is one relation which you have to remember. Okay, I am telling you directly. Neta is the porosity of unexpanded, and neta expanded is the porosity of the expanded filter bed. So the formula is D bracket 1 minus neta G minus 1 is equal to D expanded bracket 1 minus neta expanded bracket G minus 1. This relation you have to remember so that you are able to estimate after giving the backwashing process how much expansion can occur, right? So you can see here, guys, G is nothing as that is basically specific gravity of particle which will not change before expansion, and after expansion you can cancel these two values easily and you will get a relation directly, guys, which is basically D bracket 1 minus neta, and it is equal to D expanded 1 minus neta expanded, right? That is your relation which you have to remember. Now the question is, neta expanded will depend upon some empirical formula, right? Neta expanded will depend upon some empirical formula. So neta expanded is nothing as VB by VS. What is VB? That is basically velocity of backwash. Velocity of backwash, right? Velocity of backwash. And what is VS? That is your settling velocity in transition condition. Settling velocity in transition condition. Clear? Why I am saying transition? Because when particle is trying to settle after the backwashing, these particles are flowing in a transition way, right? That is the reason, guys, due to which you have to consider the settling velocity of particle as per the transition law. So as per transition law, you know that, guys, how we can write the settling velocity? It is basically under root of 4 by 3 G minus 1 into G into D divided by CD. Now the CD value is nothing as it is basically 24 by RE plus 3 by root RE plus 0.34. And that is your formula for drag coefficient. Clear? That is your formula for drag coefficient. Clear? So after putting this value, guys, in this particular VS, you are able to estimate the settling velocity. Once you will get the settling velocity, you can put over here, you will get the neta expanded. After getting neta expanded, guys, you can put over here, you will get the further value which you required, like D expanded or D or something else. Okay. So this is the formula which you have to remember in case of filtration part. Okay. Now let's move to the disinfection part. Let's move to the disinfection part. which is basically chlorination. Disinfection means chlorination. So if we talk about chlorination, guys, you know that there is one general reaction which is mostly used in our chlorination part, and on that particular reaction they are trying to ask the question regularly, right? So you know that, guys, when Cl2 is trying to react with the H2O, what it will get exactly? It is giving us HOCl and plus HCl ion, right? Now this HOCl will further break, and this HOCl will get break in H plus ion and OCl negative ion. Clear? Now this reaction is very important for us, right? So guys, there are two directions of the reaction. One is forward, right, in which you can write here K, right, rate of reaction constant, and backward direction also is possible, that is also K, right? We will write here K dash. Okay, so guys, how you can write this K value? So K is nothing as product upon reactant. So it is H plus ion concentration, OCl negative ion concentration divided by HOCl ion concentration. But all the concentration should be in moles per liter. Clear? Similarly, guys, if you have backward reaction, so for backward reaction, the formula will become what? HOCl ion concentration divided by H plus ion concentration and OCl negative ion concentration. Understood? So in this way, guys, you are able to estimate the K dash value and K value. And let us suppose, guys, if they have given the rate of reaction constant, you are able to estimate the H plus ion concentration, which will tell us at which particular pH such situation will occur, right? So this is the concept which you have to use, and these formula are most frequent in your examination. Next one is Chick's law and Watson law. Chick's law. Let us suppose, guys, if we have a tank which is basically chlorination tank, and in this chlorination tank, let us consider the water is entering right now, and in this case let us consider N0, which is nothing as initial number of microorganism. Clear? And let us consider, guys, NT is nothing as number of microorganism after time t. NT is number of microorganism after time t, and t is nothing as, that is basically contact period. What it means actually? For how much duration your chloride which you have added in the water is having a contact with the water, right? That is basically contact period. So how much contact period is there? So generally, guys, we are considering the value of microorganism just before to this tank and just after to this tank. That's why we have to consider the duration in between these 2 points only. Okay, so that is basically our contact period. So as per Chick's law, what should be your value of number of microorganism after time t? It is nothing as N0 into e raised to power minus k into t. What is T? You know that. What is NT? You know that. What is N0? You know that. What is K? That is rate of disinfection. Rate of disinfection constant. And this value is nothing as, guys, basically in terms of time inverse. Clear? Now what is Watson law? Watson law. So as per Watson law, this relation is true, guys, like C raised to power n into T is a constant. What it means? C is nothing as, that is basically a concentration of disinfectant, and T is time period, n is a constant value which is generally given to us. If it is not given, you can consider 1. If not given, n is equal to 1, you can consider 1. Okay, so what should be your relation? It is C1 into T1 is equal to C2 into T2. Now what it means actually, I will explain it. What it means actually, let me explain it. So guys, let us suppose right now the concentration of let us consider the concentration of chloride which we are adding is 10 milligram per liter, and the time period which is taking is 10 minutes to kill 99% of microorganism. Okay, now let us suppose I am adding 8 milligram per liter of chloride. So I have to know what should be the time period which is required to have the same efficiency. That is the question. So how you can do it? By using Watson law. So as per Watson law, what you can write here guys, 10 into 10 is equal to 8 into T2. By using this formula, you are able to estimate after how many duration or after how much duration the microorganism will get killed up to 99%. You can estimate this, right? So how much you are getting guys? 100 divided by 8. So it is basically 12.5. That means only 12.5 minutes are required to have the same efficiency, but we have reduced the concentration of chloride which we are adding over, chlorine over here, which we are adding over here. Clear? So this is nothing else, this is your Watson law. Now there is one more formula guys which you have to remember. Very nice. Yes. So dosage of chlorine is equal to what? Chlorine demand plus residual chlorine. Dosage of chlorine is equal to what? Chlorine demand plus residual chlorine. We can write here. Now you know that guys, water softening technique will have different process. Just remember the name, like temporary hardness and permanent hardness. To remove the temporary hardness, we have to use the boiling process and boiling with lime. Boiling and lime. Add lime. Now second one, to remove the permanent hardness, it is lime soda process, zeolite method and demineralization process. Demineralization process. Clear? Now let's move to the next one, which is basically our distribution system, right? In distribution system, you know that guys, dead end system, gridiron system, radial system and ring system we are using to distribute the water to the consumer. Now these system will have further method of distribution, right? By which mean you are trying to distribute the water, like gravity, pumping or combined gravity and pumping system, right? So what do you mean by it? Let me explain it quickly. So basically what is gravity system? Let us suppose your water treatment plant is having a higher elevation. Your WTP is present at a higher elevation and the demand area is at a lower elevation. So we are able to supply the water easily guys in this way, right? Because this particular location is having a higher elevation over here and the demand area is having lower elevation. That is the reason we can use a gravity system over here. Abhinav, actually this particular channel is related to English only. That's why we have to speak in English, right? But soon you will have a channel in which you will get both the languages. Okay. Okay. Let's understand the next situation, guys. This is basically gravity. This is basically gravity system. This one is gravity system, right? Second system is what? That is basically your pumping system. Second one is pumping. Second one is pumping. What is pumping basically? Let us suppose guys, if the water tank which we are water treatment plant which we are having is present at a lower elevation and the demand area is at a higher elevation. Okay, Abhinav, but I think that particular subject you have learned in the some Hindi batch, right? But right now this is a YouTube channel and this is related to, means this YouTube channel is devoted to English only. That is the reason. Yes, I know that. A foundation batch. Okay. Soon you will get the session from my side in Hindi also. Okay. So if you have any doubt in if you have any doubt, you can ask me any point of time. I will explain in Hindi. अगर आपको कोई डाउट होगा मैं हिंदी में भी बोल दूंगा, ऐसा कोई इशू नहीं है. आप हिंदी में पूछेंगे मैं हिंदी में बोल दूंगा, कोई दिक्कत नहीं है, राइट? अगर आप हिंदी में पूछेंगे तो मैं हिंदी में बोल दूंगा, कोई दिक्कत नहीं है, ठीक है अभिनव, ठीक है चलिए. So let us suppose guys, if you have this particular water treatment plant which is present at a lower elevation and this gravity system at a this demand area is at a higher elevation. So how you can supply it? You need to use it pumping system. First you have to pump the water. So that it will reach to the higher elevation point. That means basically a overhead tank. Right? Now through this overhead tank we will supply the water to the city area again. Understood? That is your pumping system. Now the third one is your combined system. That means for some length we are using the gravity system, and for rest of the length we are having the pumping system. That means what? Let us suppose guys, this is your water treatment plant. Through this particular water treatment plant we are supplying the water to the city area, but we are not getting the sufficient head to supply this water to the whole area. And in that situation guys, what you need to do is you need to pump this water again to the overhead tank, and then you have to supply it to the city area. That is basically combined system. Clear? That is basically combined system. So this portion is gravity and this portion is pumping. Clear? Okay. Now guys, you know that there is one distribution reservoir which you have to design, and that distribution reservoir will have three type of discharges which you have to store. One is balancing storage or equalizing storage, second is breakdown storage, and third one is fire storage. So if you add all three values you will get the design discharge, right? Now this balancing storage can be estimated by using mass curve method and analytical method. Okay, breakdown storage, it is equal to how much? It is basically 0.25 times of QD. Whatever total design discharge is there guys, out of that total design discharge you have to consider 25% of it as a breakdown storage. What is breakdown storage? Let us suppose guys, if some treatment unit is not working and it go under the maintenance part, so in that situation we need to still supply the water to the consumer. So in that particular case you need to use this particular water which you have stored in your distribution reservoir, right? Okay. Thank you Abhinav, thank you Abhinav, thank you so much, thank you so much. आपका बहुत बहुत धन्यवाद. आपने अगर आपकी मैं मदद कर पाया हूँ और आप लोगों को बहुत अच्छे से मैं पढ़ा पाया हूँ स्ट्रक्चर, तो थैंक यू सो मच. ठीक है, चलिए अगर मैं बात करूं बच्चों, इफ वी टॉक अबाउट द फायर डिमांड, सो फायर स्टोरेज इज नथिंग एज इट इज द अमाउंट ऑफ वाटर विच वी हैव टू स्टोर, राइट? In case of fire breakdown you need to supply it, so this value should be in 1 to 4 LPCD value, right? So that's it guys. Okay, this is for your water supply engineering part, and the next portion which is basically our wastewater engineering, that we will discuss in the other lecture. Okay, so any doubt guys, any doubt, any query if you have, please let me know. And all the formula which we have discussed today, you will get this particular PDF on my Telegram channel. I will send it guys, I will send it. And I think you got the PDF of RCC already, right? So this particular PDF also you will get today, and the next portion of environmental engineering we will discuss in the next session. Okay, thank you Sandhu, thank you so much. Okay guys, so let's close the session and let's meet in the next one, in which we will discuss the rest of the part of environmental engineering, which is basically your wastewater engineering portion. Okay, so I'm sharing a link over here guys which you can join, and ultimately you will get this particular PDF from my Telegram. Okay, okay guys, so let's close the session and let's meet in the next one. Bye guys, take care. Thank you so much for joining the session. I hope you have enjoyed it, and you have revised certain formula which you have already learned, right? So thank you so much guys. Let's meet in the next one.